130 volcanoes lie buried under Antarctica's ice. As the ice melts, these sleeping giants are stirring, and what happens next could reshape our world forever. Most people see the world's ice and its volcanoes as separate forces. One is a symbol of stillness, and the other a channel for incandescent rage. But scientists are now uncovering a surprising link between them that has been dormant for millennia. And as global temperatures rise and our glaciers shrink, this connection may be reawakening. We're already seeing hints of this across the globe. In Iceland, a country literally forged by fire and ice, scientists are watching volcanoes that are stirring after a long silence. Along the coast of Chile, there's clear evidence linking the retreat of the ancient Patagonian ice sheet to a surge in violent eruptions. But the biggest question mark lies at the bottom of the world, Antarctica. Buried under the West Antarctic ice sheet, scientists have discovered one of the largest volcanic regions on Earth. More than 130 volcanoes, many long dormant, are hidden under miles of ice, a region that may rival East Africa's famous Rift Valley in sheer volcanic density. The concern is that as this colossal ice sheet thins, these sleeping giants could begin to stir. This isn't a simple case of ice melting to reveal a volcano. The process is far more dynamic. The melting of the ice itself could be the very thing that kickstarts these geological giants. So the real question isn't if these systems are connected, but how and when they might react to the rapid changes we're forcing on our planet. But how could melting ice on the surface awaken a volcano miles below? The mechanism is a powerful lesson in planetary physics, and it's all about pressure. Imagine a glacier thousands of feet thick. All that ice adds up to an unimaginable weight, a colossal lid pressing down on the Earth's crust. This immense pressure physically squeezes the rock, clamping down on the magma chambers below and helping to keep them contained. For thousands of years, this has acted like a planetary safety valve. But now that lid is being lifted. As climate change accelerates ice melt, that weight is being removed. Geologists call this isostatic rebound. As the pressure on the crust lessens, the rock below begins to relax and flex upwards. Crucially, this pressure drop is felt deep below in the magma chambers. This is where things can get explosive. To understand it, think of a magma chamber like a bottle of soda. The magma contains huge amounts of dissolved gases, like water vapor and carbon dioxide, held in check by the intense pressure. When the ice above melts, it's like slowly unscrewing the cap. As the external pressure drops, those gases can suddenly come out of solution, forming bubbles in a process called volatile exsolution. These bubbles drastically increase the volume and internal pressure of the magma, making it more buoyant and explosive. The chamber swells, fracturing the rock around it and creating pathways for the now furious magma to escape. The result isn't just an eruption, it can be a more explosive eruption. This isn't science fiction. The evidence is already in the rocks beneath our feet. We know this isn't just a theory because the Earth has run this experiment before. At the end of the last ice age, around 10,000 years ago, Iceland experienced a volcanic firestorm. As its glaciers rapidly melted, the island's volcanoes erupted at a rate 30 to 50 times greater than what's typical today. Geologists can read this history in the rock layers. When the ice disappeared, the fire began. Now, as today's ice sheets are changing, we are running a similar experiment, and the outcome can change the world. The process isn't always linear. For instance, the 2024-2025 Antarctic season saw above average snowfall, which partially offset some ice loss. The awakening of subglacial volcanoes isn't just a spectacular geological show. It could be a catalyst for cascading consequences. The most alarming possibility is a positive feedback loop, a cycle where melting ice triggers eruptions, and those eruptions in turn accelerate the melting. Nowhere is this theoretical loop more concerning than in Antarctica. The West Antarctic ice sheet is already considered vulnerable because its base rests on bedrock far below sea level. Now add volcanic heat to the mix. An eruption beneath several kilometers of ice releases immense heat, melting the ice from the bottom up. This can create vast subglacial lakes and lubricate the base of the ice, speeding up its flow towards the sea and contributing to faster sea level rise. This is where that terrifying feedback loop emerges. Step 1. Global warming melts the ice. Step 2. The pressure release potentially triggers a subglacial eruption. Step 3. The eruption's heat melts even more ice from below, further weakening the ice sheet. And Step 4. This accelerated ice loss further unloads the crust, which could, in theory, increase the likelihood of more eruptions. Beyond this loop, there are other immediate dangers. An eruption under the ice could send a flood racing toward the sea in a catastrophic event known as a Jogelklaup. These glacial outburst floods can release volumes of water comparable to the Amazon River, destroying everything in their path. Globally, a surge in volcanic activity would also affect the climate. Large eruptions inject massive amounts of sulfur aerosols into the stratosphere, which reflects sunlight and can cause a short-term global cooling effect for a year or two. We saw this after the 1991 eruption of Mount Pinatubo, which temporarily dropped global temperatures. However, that cooling is fleeting. The same eruptions also release greenhouse gases like carbon dioxide. It's critical to keep this in perspective. All of the world's volcanoes combined emit less than 1% of the CO2 that human activities do. So, while a sustained increase in volcanism would add to the long-term warming problem, it would not rival our own emissions. The Earth is a deeply interconnected system, where the oceans, atmosphere, ice, and solid rock all influence each other. For a long time, we focused on the surface symptoms of climate change, but the slow, creeping changes happening deep in the Earth's crust may pose a greater, more surprising threat. The link between melting ice and volcanic fire is a stark reminder that our actions can have consequences we are only just beginning to understand. The volcanoes of Antarctica and Iceland aren't just mountains of rock. They are part of a dynamic system that is responding to the pressure we are putting on it. If you found this look into our planet's hidden connections interesting, please consider liking and subscribing for more deep dives into the forces that shape our world. Your support helps us to tell these critical stories. The planet's past is written in the rock, from the plains of Iceland to the peaks of the Andes, giving us a clear warning. The question is whether we will heed it, or wait until fire and ice collide in a way that could reshape our world for centuries to come.